Today, let's talk about 2020 AMC 10A problem 24. Let n be the least positive integer greater than 1000 for which the GCD of 63 and n plus 120 equals 21, and the GCD of n plus 63 and 120 equals 60. So what is the sum of the digits of n? Let's first do a GCD analysis. So we know that 21 is 3 times 7. That's just like basic times tables. This means that n plus 120 must be some multiple of 21. Let's just call that something a. Now notice that a is not divisible by 3 because so the GCD of a and 3 is 1. A does not have a multiple of 3 because let's say a is a multiple of 3. So let's say a is a multiple of 3. Then we know that 63, and we know that GCD would be 63 because GCD 63 is 3 squared times 7. The reason that GCD only has one multiple of 3 is because this number only has one multiple of 3. If this number is divisible by 9, then GCD would be 3 squared times 7 or above. And the second thing is we know that 60 is 2 squared times 3 times 5. So this means that n plus 63 is 60 times b. b being an integer. Now 120 is 2 times 60. So 120 is 2 cubed times 3 times 5. So this means that since the GCD only has 2 factors of 2, not 3 factors of 2, b only has 2 factors of 2. So 60b only has 2 factors of 2, so b is not divisible by 2. So the GCD of b and 2 equals 1. So now we have like 2 equations and 3 values, so we can't really solve for anything. But maybe we can try and merge these equations together in some sort of way. For example, if we want to at least cancel a variable out, we can cancel n out by subtracting the equations. So if we subtract the equations, we have 120 minus 63, which is 57, equals 21a minus 60b. Okay, so if we divide both sides by 3, we know that 19 is supposedly equal to 7a minus 20b. So what does this tell us? Firstly, it tells us that 7a must have a unit digit of 9, because this has a unit digit of 0. And so as long as this has a unit digit of 9, the unit digit of our difference between 7a and 20b would be 9. So what unit digit of a makes 7a have a unit digit of 9? A must end in 7. So a must equal to something something 7. Right? Okay, so and b can be something random. So another thing we want to look out for is the value boundaries of a and b. Because we know that these numbers here, so we know that n must be larger than 1000. So this means that n plus 120, or 21a, must be larger than 1120. So a must be larger than 53, or a is larger or equal to 54. So the smallest value of a here that ends with a 7 is 57. So, but we'll talk about that later. And we know that 60b is n plus 63, so it has to be larger than 1063. So b is larger than 400, so 106 divided by 60 is 1, remainder 46. 463 divided by 6 is 7, remainder 43. So b is larger or equal to 18. So the smallest value for b is 18. So now let's just there's nothing much we can do anymore. Well, unless we know how to solve Diophantine equations. So basically, let's just first, but an easier way without solving Diophantine equations, or if you don't have the skill, then just list out all the numbers, all the possibilities for a and b, because you know that it's not going to be really far away. So let's try 57 because that's the smallest value. But we know that the GCD of A and 3 must be 1. 57 is a multiple of 3. It's 3 times 19, so this doesn't work. What about 67 then? Let's look at 67. 7 times 67 is, so 7 times 7 is 49. 7 times 6 is 42 plus 4, which is 46. So this is 469. Now what's 469 minus 19? Well, that's 450. However, we know that 450 is only a multiple of 10, it's not a multiple of 20. So this doesn't work. Now what about when A is 77? 77 times 9 is, well, 7 times 9 is 63. 7 times 9 is 63, plus 6 is 69. 9, so we know that. So wait, this is 77 times 7, not 77 times 9. I don't know why I wrote 9. Okay, so 7 times 7 is 49. 7 times 7 is 49 plus 4, which is 53. So 539 minus 19 is 520. So B is 520 divided by 20, which B is therefore 26. Now, does this work? Let's check this out. So, one thing to check this out is we know that the GCD of B and 2 must be 1, so B must not be a multiple of 2. But 26 is a multiple of 2, so this does not work. So, sad. Let's just continue. What about 87? Well, the GCD of A and 3 must be 1, but 87 is a multiple of 3, so this does not work. What about 97? 97 times 7 is, 7 times 7 is 49. 7 times 9 is 63, plus 4 is 67. 679 minus 19 is 660. So B is therefore 33. It looks like A and B are both within the boundaries and their GCDs are valid. But let's just test this out. Okay, so what's N then? Well, N is 21A minus 120. So what's 21A? 21A is this value times 3. So what's 679 times 3? 3 times 9 is 27. 3 times 7 is 21 plus 2, which is 23. 3 times 6 is 18 plus 2, which is 20. So 2037 minus 120. So the value of N is supposedly, so 7 minus 0 is 7. 3 minus 2 is 1. 20 minus 1 is 19. So the value is supposedly 1917. Now let's look at a few things. Firstly, is the GCD of 63 and N plus 120 equal to 21? We know that 2037 is 3 times 7, or 21, times 97, and 97 is prime. So yes, that works. Now is 1917, so is N plus 63, is the GCD of N plus 63 and 120 60. Well, what's N plus 63? N plus 63 is 1980, which is equal to, so we divided by 60, so this is 60 times, so 19 divided by 6 is 3, and then 18 divided by 6 is 3. So this is 60 times 33, so this also works. So the answer is 1917. So that if you sum the digits up, 1 plus 9 plus 1 plus 7 is 10 plus 8, which is 18. So the answer is 18. Thanks for watching.